Ahoy there, matey! Welcome to my ship, the Rising Tide. Right now, we're sailing down the Mississippi River, heading to deliver some parts to a friend for their latest engineering project. We're coming up on water that should be too shallow for my ship to pass through. Thankfully, engineers have designed a special structure to get my ship through safely, and that's called a lock and dam system. I'm Annika, a first-year student studying creative technology and design at CU Boulder, and while I'm here waiting until we pass through the lock, let's take a deep dive into what a lock and dam system is. Water vessels are a great form of transportation. However, when a boat is moving down a river, there are a lot of problems it could face. Sometimes, a boat needs deeper water than a portion of a river has, so it gets stuck, like mine almost did. Other times, the river drops too steeply for a boat to safely make it through. And sometimes, the river takes a plunge thanks to a waterfall or a human-made dam, which a ship definitely can't navigate past. For these situations, engineers have designed a lock and dam system. A lock and dam system is designed to move boats between sections of water that are at different levels. It's kind of like a staircase with only one step. However, boats don't have legs to step up or down a staircase with. Since the boat can't move on the staircase has to move the boat, which I suppose makes it more like an elevator than a staircase, but whatever you call it, let me show you how engineers move boats like this. Let's assume a ship is going downstream. In this diagram, that means it's moving from left to right. You can imagine a lock as a giant container in the middle of a river that you can either fill up with water to raise the water level or empty out to lower it. When a boat first pulls up to the lock, both of the gates, the doors on either side of the lock, are closed. The filling valve, which is a little door underneath the water, opens up, allowing water to flow inside the lock and raise the water level. Once the water has reached the correct level, the upstream gate opens, allowing the boat to move into the lock. Then the upstream gate and the filling valve close, trapping the boat within the lock. Now the second underwater door, the drain valve, opens up, letting water flow out from the lock and lowering the water level until the boat is level with the water on the other side. Once it is, the downstream gate opens, and the boat is free to keep moving wherever it's headed. For a ship going upstream, in this case right to left, this process is reversed. First, you drain the lock with the drain valve. Then you let the boat in. Close the gate behind them, let in water with the fill valve, open the gate in front of them, and voila! Your boat is traveling upstream. It's a pretty neat process, right? Once one of these things is built, boats can use it over and over, making sure water travel is easier for everyone. However, when an engineer designs a lock and dam system for a particular chunk of water, they have to keep in mind how the water will push on the structures. And to do that, engineers have to remember Pascal's law. Pascal's law describes how water at a given depth exerts the same pressure in all directions. It's represented by this fun little formula, P equals rho GH. The P is pressure. The thing that looks like a lowercase p is the Greek letter rho, which is the density of the fluid. The G is gravity, and the H is depth. In the case of lock and dam systems, rho is 1,000 kilograms per meter cubed, since that's the density of water, and gravity is 9.81 meters per second squared, since that's what gravity is here on Earth. That leaves the depth of the water as the only thing affecting the pressure. So, the deeper the water, the greater the pressure, and the stronger the structures around the lock the engineers will have to build. And I sure am glad they made the lock and dam system that I just sailed through strong enough. Without it, my ship wouldn't have made it past that part of the river, and my friend would never get these parts. The lock and dam system makes water travel a lot easier. It also ensures that any delivery that relies on a boat, like mine, can travel safely to its destination, improving waterside economics. Thanks to this system, we all know that when we order something that we need to complete a project, we'll get it, and we can all be more efficient engineers. Check out the full lesson on TeachEngineering, then use what you learned about the dam and lock system and Pascal's law in the associated activity Under Pressure.